If we have a graph, we can find our zeros, our real zeros, fairly easily and determine their multiplicity based on their behavior around the x-axis and write an equation as a product of the factors. So let's look at a couple things before we get started. If you notice right here, they're giving you the window of this graph. This part right here is telling you that your x's are negative 20 through positive 20. So we know this side over here is negative 20 and over here is positive 20. And we are counting by twos. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The second part is your y's. And we have a low of negative 100 and the highest y on here is positive 100 and every tick mark shown is 25. So you're counting by 25s as you go up and down the y-axis. You need to make sure that you look at that before you determine your zeros or you could mess up a little bit. All right, so let's look at this graph and talk about the zeros and the behavior as that graph touches that x-axis. So when the graph touches the x-axis, those are our real zeros. And right here, you'll see that we touch and turn back around. So we know that this zero right here, x equals 0, has even multiplicity. And it is going to touch and not cross. This zero right here crosses like a line, so it has odd multiplicity. And let's figure out what that zero is. So the x's are counting by twos, remember, so 2, 4, 6, 8. So that is x equals 8. It has odd multiplicity, and that means that it's going to cross the x-axis. Once we have that, we also want to look at end behavior. We can determine that the degree of this graph has to be odd because the left and the right side are different. And we can also determine that the leading coefficient must be negative because the right side falls. So anytime the right side falls, the leading coefficient must be negative. Now we have all the information we need and we can go ahead and write our function. We want to turn our zeros into factors. So this as a factor is just x and this as a factor is x minus 8. Now we need to look at our multiplicity. X equals 0 has an even multiplicity. If you notice up here it says make the degree as small as possible. So even multiplicity as small as possible would be x squared. This has odd multiplicity. As small as possible would be 1, but more importantly, you should notice that it crosses like a line, and anything that crosses like a line is going to have linear behavior with a multiplicity of 1. So we don't need to write an exponent here. There is one, it's a 1, but we don't have to write it. We're ready now to write our function. So this function, we could say f of x equals, our leading coefficient needs to be 1 or negative 1. And we determined here that it must be negative. So we're going to write a negative 1 leading coefficient. So we're going to write negative x squared times x minus 8. And that is a good equation for this graph.